Hello, I'm Weng from Rensselaer Polytechnic Institute presenting interactive contract negotiation learning with generative AI agents. This project explores how generative AI agents can enhance supply chain management education. In our simulation, students negotiate contracts with an AI supplier, place orders under demand uncertainty, and observe how their decisions affect outcomes like profit, return, and inventory risks. The main idea is to move negotiation learning beyond static cases, spreadsheets, into an interactive, repeatable learning experience. Contracting and negotiation are core activities in supply chain management, but they are difficult to teach through traditional methods. Students need to reason about uncertainty, strategic interaction, and trade-off between cost, risks, and flexibility. Traditional approaches can explain contract concepts, but they often do not capture the back and forth and behavioral nature of real negotiation. A key part of the system is the AI supplier. The goal is not just to generate conversations, but to support negotiation practice around contract trade-offs. For example, students may try to negotiate a lower wholesale price, but that may require accepting more inventory risk through a lower return cap or different revenue sharing terms. The AI supplier gives students a more dynamic negotiation partner than a fixed spreadsheet or a simple rule-based response. This project implements a fashion supply chain scenario where students play the role of retailers negotiating with suppliers. The simulation is structured around a 4-phase learning loop: briefing, negotiation, feedback, and execution. In each round, students review information, negotiate contract terms when possible, make an ordering decision, and then receive simulated outcome feedback. In the briefing phase, students review past demand history and the current contract status. In the negotiation phase, they propose terms such as wholesale price, buyback price, return cap, contract length, and revenue sharing. In the execution phase, they choose an order quantity under the active contract. In the feedback phase, the system simulates market outcomes and presents performance metrics. Here's a figure of the student user interface. Behind the scenes, the project uses a web server to manage session states, contract parameters, demand simulation, and AI model orchestration. The LLM is given a constrained, context-aware prompt that includes contract terms, demand history, game context, and negotiation rules. This allows the AI supplier to generate responses that are more connected to the simulation. The important design choice is that the AI response is structured so the backend can interpret it, validate it, and update the simulation state. Before showing a short demo, here's the prompt structure behind the AI supplier. Pause the video as needed. With that in mind, here's a working prototype. As you can see, I just started a new game. After filling out the proposal and submitting it, you enter a chat interface where you can negotiate with the AI agent. After an agreement is reached, a proposal contract is drafted. Now, the student can place orders. Within this interface, the student can see demand history. Now, the proposed contract will be declined and the conversation will continue. We can check out some session data from the interface after we end the game. This figure gives a closer look at the negotiation process. First, the student submits or revises contract terms. The system then builds a prompt using the proposal, demand history, game state, negotiation constraint, and prior chat history. The AI supplier evaluates the terms and returns a structured response. Depending on the results, the contract may be accepted. The students may continue negotiating, or the backend may validate a finalized contract. Once a contract is active, the students can place orders and observe the simulated outcomes. Our evaluation plan has 2 stages. The first stage focuses on whether the students can understand the interface, contract terms, demand information, and AI responses. The second stage focuses on whether repeated negotiation helps students adapt their strategies and better understand supply chain contract trade-offs. The planned data sources include surveys, structured feedback, think aloud observations, interaction logs, pre/post assessments, and student reflections. Overall, this work demonstrates how generative AI can support learning in supply chain contracting. By integrating adaptive agents into a simulation environment, the system gives the students repeated opportunities to negotiate, make decisions, observe consequences, and refine their strategy. Future work includes multi-agent configuration, improved instructor controls, persistent data storage, and broader classroom deployment. Thank you for viewing our poster. Thank you for viewing our poster.